For this problem, we are to solve for the value of A, B, and C for the entire linear system to be consistent. Don't forget that when you say consistent, there is a solution. And it could be one solution or infinitely many solutions. For when we say inconsistent, there is no solution for that. So we are going to represent our results later on in terms of A, B, and C, and let's find out what is the relationship of this mentioned representation of the coefficients as to making the linear system to be consistent. Here, we will try to come up with a row echelon form using the Gaussian elimination. So first, let us have this matrix: 1, 3, -1, and 8. Okay, don't worry about A because we are going to represent our answer in terms of A, B, and C. Next, 1, 1, 2, B. Next, 0 because we don't have X. 2, -3, and then C. So we will just simply apply series of row operations in order for us to reach a row echelon form of this, and whatever be the result here at the bottom later, that would be our representation for A, B, and C for the linear system to be consistent. Okay, so let's try to apply this set of row operations. I'm going to make this 0 first. So -1 of row 1 plus row 2 for a new row 2. So this would mean our new matrix is 1, 3, -1, still A. This would be -1 times 1 is -1 plus 1, 0. -1 times 3 is -3 plus 1, -2. Next, -1 times 1 is +1 plus 2, 3. Next, negative A. -1 times A is -A plus B. So -A plus B. And for the third row, still 0, 2, -3, and then still C. Okay? Then, let's try to multiply -1/2 to our row 2 for a new row 2. And we are also going to make this equal to 0. We could use the result of this, but we could just simply attack this at once using the original row 2 here. So let's try to add row 2 plus row 3 for a new row 3. But again, the row 2 is not this result, but the original row 2. So let us have this next version. So the first row is still 1, 3, -1, 8. And then we are going to multiply -1/2 to all entries on the second row. 0, 1, -3/2. And we also have -A plus B all over 2. Now don't worry about that fraction form because our goal is again the bottom portion here. Okay. So we'll add. So you will have R2 plus R3. 0 plus 0, 0. -2 plus 2 is 0. 3 plus -3 is 0. And you add this to that, -A plus B plus C. So we are done with our row echelon form. You can notice here, leading ones, the row with 0 entries are here, and of course the situation or the placement of the leading ones. So when can we say that this linear system is consistent based on this final form of the row echelon form? We could say it's consistent again if there's exactly one solution, or there could be more than one solution. This entire value here could not be a value greater than 0. Why? Because say for example, if this is 1, 0, 0, 0, 1, this would make the entire linear system with no solution. Okay? Because there can be no 0x times 0 plus 0y plus 0z is equal to 1, right? So this could not be equal to 1. But this could also be not less than, not negative value, like -1, etc., etc. This could only be consistent if -A plus B plus C is equal to 0. Examine what would happen if this is 0 here. The entire entry is 0. 1, 3, negative 1, 8. 0, 1, negative 3 halves, negative a plus b over 2, and 0, 0, 0. And if we let that, sorry, here, you will have 0. You have 0 entries for the third row, and you will have 2 rows with non-zero entries versus 3 different variables x, y, and z. This would mean you have a free variable. In that case, you will have a arbitrary variable for one of them. That means there are infinitely many solutions now because you have 0 entries for the last row. So this is the result for A, B, and C for this linear system to be consistent. Negative A plus B plus C equals 0. Thank you for watching.